In this lesson, we're going to learn how to draw a free body diagram of a simply supported. And what I've done is looked at real life examples. So we're actually going to develop a free body diagram in a real life example. So what I did was I searched for machine tools, and there's plenty of examples of simply supported for free body diagrams. You'll see them all throughout your textbook in more simplified version, but this is a realistic version of a simply supported beam. So let's take a look, and we're going to take a look at this orange piece. And this orange piece is used as a lathe chuck guard, so you don't put your hands in there and get cut, or worse yet, lose your hand. So let's look at this. So if you notice that connecting this orange piece, this sheet metal piece, there's a bunch of nuts and bolts, and then you'll see in these little black pieces, and they're connected to this extruded aluminum rod. So we're going to focus right there. So right there, if you look at the black pieces on this side, they're actually on pivots and pins. So we're going to model what pins look like, and I'm going to show you, I'm going to draw this in before, I'm going to draw this in, I'm going to sketch this for you, but I'm going to put the pins there. And also notice there's this little L bracket up here, and it's going to support, help support all this weight of this sheet metal. This is actually when it's down. So here's a better example. And underneath, you can't really see what's being supported, but you know right here it's being supported with this roller type of thing. And it's rolling because it could free to rotate. It's free to expand in this direction along this orange piece here. So if we take a look at this, we'll notice that it shows the pin, but it doesn't show the stopper. That is a mistake, I think, on the drawing, or maybe it's incomplete. I'm not sure. So we're going to draw this orange piece with this, with the hinge and with this stopper, but we're going to change it up a little bit. So let's do that, and we're going to come back and forth and reference this picture. So let's take a look, and let's start drawing what looks like the orange piece for a free body diagram. So again, it comes out this way, and then it kind of comes down, and it covers this. It kind of comes up, and we're going to draw this just simply beam of some sort. So right here, right here, you have this connection piece, and we're going to usually you see these drawn some sort of frame reference. So this reference frame, and then we're going to draw this, and we're going to say this is a pin. So this pin connection is what you see over here. I know it's a little abstract. It's not the exact dimensions or the exact notion, but you notice that this pin here is connected to this frame. We're going to call this a frame because this is we're going to assume this is a rigid body. And therefore, these little lines here represent the rigid body. So if we go back here, which is off of this, but if you look up here on one of the first things, you'll see right here is where I'm going to put my roller. Again, a roller, in a sense, in this case, we're going to assume frictionless, although that's not true, because there's this pad there, and I'm assuming it's made out of some rubber to stop the noise and the vibration. But we're going to limit that, and we're going to put the roller right here. And again, we're going to eliminate this, and we're just going to call that there's a roller right here, and it's attached to the same frame. So when it's attached to the same frame, it just looks like this. So I'm just isolating first this orange piece right here. And I'm saying it's pinned here, and it's on a roller right here. Again, it's on the same frame. So nothing magical, but this is how real life analysis would be done. So this was it before the free body diagram. So we haven't done a free body diagram for this. So let's do one now, and let's see, and let's replace this pin connection. Let's replace this roller and put some reference frame or some inertial frame coordinate system on here, and let's put a weight on here. So take a look, and we're going to redraw this orange piece. Now let's pick orange, and we're going to come down here. So we're going to, again, it doesn't have to be accurate to some sense. You just have to make sure to get the free body diagram right at this stage. So furthermore, we're going to replace the reactionary forces from the pin connection. I'm going to put a pin connection here. And we're also going to put a coordinate system right at that pin. I'm going to put an X and a Y. This is a standard way to do things. It's X and Y direction. So with that, we have this little blue dot, but we don't have any forces, and we can represent these reactionary forces with a vector. And even more so, we can represent components of a vector just for now. And we recognize that if we put the components of the vector, what we want to do is we want to put them in line to make it easier for us, in line and parallel in the line of action of this x-axis here. And we're going to call this at pin A, sort of point A on here. We're going to call this the F of A. The F stands for force vector. The force A represents the pin, and we're going to put X, which represents the direction. Now, it's standard practice to put them all in the positive direction when doing releasing the pin and putting in place vectors. And then we're going to put one for the Y direction. And we're going to say that's F of A, Y. So again, I took out the pin, and I replaced it with two vectors. We don't want to overdo this. So if we don't want to sit there and do this, that is a big no-no. We don't want to do that because that's saying that there's a force here, an applied force or a load, and also a reactionary. That's not what's happening here. These are reactionary forces that's going over to this weight. So if we keep continuing on with that scenario, we're going to replace again with this roller here, and we're going to call this, we're going to say that we're going to replace that roller. We're going to call that B, that point B. We're going to say that that is F of B. Again, we're replacing the roller with a force vector here. And then what we're going to do, and we're going to do it in the positive direction, and then what we're going to do is we're going to estimate the weight of this, and we're going to say that that's a downward weight because we can assume there's gravity in that direction with a big W. Again, this is how a free body diagram's complete. So this would be a complete free body diagram even before you start your equations. This is the most important step in statics to create a free body diagram. If you get this wrong, your problem and your analysis will be incorrect. It all starts with a free body diagram. Have a great day.